it. So this is an irreducible polynomial, characteristic polynomial, prime polynomial. So you have to multiply this into this with respect to mod this. So please solve it. I think all of you have copied this.
Yes.
Now you can tell me the answers step by step. So first tell me the answer before reduction. Before reduction कितना आ रहा है?
Sir, x to the power 12 plus x to the power 7 plus x.
एक एक करके बताओ. मोहित आप बता रहे हो तो बताओ.
Sir, x to the power 12 plus x to the power 7 plus x.
Just a second. फिर से बताओ क्या बताया? मोहित.
Sir, x to the power 12, x to the power 12 plus x to the power 7 plus x.
X to the power 12 plus x to the power 7 plus
x.
अच्छा, सबका यही आंसर आया है या फिर किसी का दूसरा कुछ आया है?
X square at the end, sir. X power 12 plus x power 7
Yes,
plus
sir,
x square.
Right.
X square, sir.
Himanshu, you are correct. Himanshu, and who answered previously? नाम बताओ.
Supriya, sir.
Supriya, you are also correct. But Mohit, your answer is incorrect. So, is it possible for Supriya or Himanshu to show the calculations in camera?
I can show send picture.
Yeah. Yeah, you can take the picture and can.
Yes, sir.
Acha. Who is the host of this meeting? Manish or someone he said?
Sure, I am the host.
Okay. So you change the setting so that everyone can see the screen. There's an option you can check. Yeah.
Yes, sir, I have already allowed.
Okay, you have already done. Okay, so Himanshu or Supriya, you take a photo and then share your screen and then show us.
So I have sent to you email.
Huh? You
So I have sent
email?
to. Yes, sir.
To whom? Acha.
Sir. Yes, sir.
So these are your calculations. Others can see and can check. So this is correct. Now you do the reduction. That means you have to calculate this modulus that remainder of this division. So you do, and whenever done, inform me.
Sir, I've sent you the mail.
Okay. So the result is x to the power 4.
Sir, plus 1.
Yes, sir, plus 1.
Supriya, your result is x to the power 4. This has been sent by Supriya, na?
Yes, sir. Yes, sir. Sir,
So
actually,
your
it's x to the
result
power x to the power for 4 plus 1, sir.
Okay, but you have put it here.
Yes, sir.
You should have put it here as
Yes,
plus.
yes.
Okay.
Yes,
So
sir.
you got
Yes,
4 plus 1. Okay. Otherwise, it is correct.
sir. Okay, sir.
So who else have done? Somebody else was answering x to the power 4 plus 1. Na? Who was answering?
Yes, sir.
Kathy.
X plus 4 plus 1. Yes, sir.
Yeah. Please send me the photo.
I'm sending, sir.
Anand Kumar Maurya also have sent. This is not minus, you can put plus. Manohar, you are noting down the performances, na?
Yes, sir.
Okay.
Himanshu, Supriya,
Anand
Kathy has
Kumar
responded.
Maurya has
I'm
done.
also noting down all the
Yes,
responses.
sir.
Himanshu Joshi. Himanshu Joshi has done it. The reduction also. Okay, that's all. Now going to the next part. So you tell me these are the two operands, two things you have multiplied, the characteristic polynomials with respect to another characteristic polynomial. So tell me the binary string corresponding to these three characteristic polynomials. Obviously, the first two you have to tell in 8-bit format, whereas the modulus polynomial you have to tell it in 9 bits format. So tell me the strings.
Hello, sir.
Yeah, Supriya.
Yes, sir. So it is 001 001 10
Yes,
100 11 110
yes,
100 011 011.
correct. So the question may be given in this format or the question may be given in this format. But please note that you cannot multiply, unlike addition, which you can directly do in the binary string also. You cannot directly multiply the two strings. You have to first convert it in characteristic polynomial, then get the result, whatever you have obtained, and then what should be the result then? You have said the result is x to the power 4 plus 1. So that means this is 4, 3, 2, 1, 1 and 0. 1 x square x cube x to the power 4. 1, 2, 3, 4, 5, 6, 7, 8. So this would be the result. And this way you can solve. Okay, so you have learned. Now we'll see. So multiplication you have learned, this is the way to do the multiplication. Now we'll see how to calculate the multiplicative inverse. Additive inverse, we have already seen that for a string, additive inverse is the string itself. But how can we calculate the multiplicative inverse? Now, in order to calculate the multiplicative inverse, we need to use the extended Euclid algorithm. Extended Euclid algorithm has been discussed in cryptography so far or not? For calculating the multiplicative inverse of any integer modular arithmetic, we use this algorithm. Has it been discussed in cryptography course already or not? Please tell me yes or no. मतलब आपको पता ही नहीं कि it has been discussed or not. Meaning even you do not know whether it has been discussed or not. See, this is the algorithm. This is the simple Euclid algorithm, meaning not extended version. You have to calculate, two inputs are given, B and N. You have to calculate the inverse, multiplicative inverse of B with respect to mod N. Multiplicative inverse of B with respect to mod N you have to find. So this is the algorithm. So we take two variables R1 and R2 initialized to N and B. Now while R2 greater than 0, you repeat this thing, Q is equal to R1 divided R2. Note that this is the division symbol. That means this will give you, Q is defined as an integer. So it will give you only the quotient. This is only to get the quotient. This will not return in decimal. This will return in integer only. Like the C division, if you define Q as the integer. And then R is equal to R1 minus Q R2. Okay. So what are we doing? So we have to calculate the multiplicative inverse of B with respect to model. So actually we are calculating the GCD of B and N. Now how to calculate GCD of Bn? You have learned the division method. So you divide N by B. Okay. So here, this position we are saying it R1, meaning the dividend is R1 and the divisor is R2. Now you will get some quotient and you will get some remainder. Okay. So Q is R1 by R2. Now note that dividend is equal to divisor into quotient plus remainder. That means R1 is always equal to Q R2 plus R. So that means R is equal to R1 minus Q R2. So that exactly what we are doing. That means simply saying we are first calculating the quotient and then we are calculating the remainder. If you have that modulus symbol provided by the C, then you can also use R1 module R2, but this is a generic algorithm, assuming that only you have plus, minus, multiplication and division symbols. So then this. Now what you do in your childhood, what you have learned, we have to put it here. We have to keep B here. That means R1, R is becoming R1 and R2 is becoming R, and in place of R1, meaning the divisor is becoming R and the dividend is becoming B. So who is taking whose place? R2, you are taking the value of R, and R1, you are taking the value of R2, current value of R2. Meaning this should be fast actually. R1 taking the value of R2 and then R2 taking the value of R. Okay, this will continue until R2, meaning the divisor is greater than 0. Okay. Now when the divisor is equal to 0, then you tell me which one would be the GCD of Bn. R1 indicates the dividend, R2 indicates the divisor. Now in this way to continue, then whenever R2 is becoming 0, that means the divisor becoming 0, when it can happen. And then what would be the GCD? Tell me. बोलो. जैसे कोई भी ले लो. Suppose you have to calculate the GCD between any two number, you say 4 and 10. So 4, 10, 2, 8, 2. Now you keep 4 here. So this is becoming 0. Now again you repeat here. No? So that means when the divisor is becoming 0. Now then which one is the dividend? Sorry, which one is the GCD? Usually आप लोग क्या करते हो जब यहाँ पे ये खत्म हो जाता है तो this is the GCD. But we are continuing the loop once more until the divisor becomes 0. Then in that case, since it is coming here, then the dividend, current dividend is the GCD. Have you got it? So that means the GCD is equal to R1. Up to this point, you have understood or not? Whenever R2 is 0, R1 is becoming the GCD. You have understood or not? Mohit,
Yes, sir.
Yes, sir.
Yes, sir.
Himanshu,
Yes, sir.
Supriya, Kathy.
Yes, sir.
Yes, sir.
Yes, sir.
Good. Now you remember that we can get B inverse with respect to model only when the GCD is 1. So if you have to check if R1 is equal to 1, because if the GCD is not 1, that means they are not mutually, meaning they are not coprime. In that case, you will not get the GCD. So if they are coprime, then what would be the multiplicative inverse? Now, this algorithm is the original Euclid algorithm to get the GCD. Actually, you can return here, you can write return R1. That is the GCD. And that is the original, this is the original algorithm, Euclid algorithm. But now, extended version I'm showing here, you have to take two more variables, T1 and T2, and you have to initialize them as 0 and 1. T1 is equal to 0 and T2 is equal to 1. Now, two more steps you have to add here, like you have calculated this thing, R is equal to R1 minus Q R2. You have to take another temporary variable, T is equal to T1 minus Q T2. Similar to this, T1 minus Q T2. Now, similar to these two steps, you have to do the interchange. So what are you doing? You are taking T1, T2, and then you are taking T2, T. And finally, when R1 is 1, you return T1. T1 is the multiplicative inverse. Okay. See this algorithm. So this is the extended version. We took two more variables, T1 and T2, initialized to 0 and 1. Then like this, we incorporated this statement, T is equal to T1 minus Q T2. Then like these two steps, we include two more statements, T1 is equal to T2, like R1 equal to R2 you took, and T2 is equal to T. Just 1 second, I'm coming. So this is the algorithm. Now I'll demonstrate it with an example. Suppose you want to calculate, like it is given in the book, 11 mod 26, 11 inverse, multiplicative inverse of 11 with respect to 26. So apply the algorithm and then calculate. This is the algorithm. So how are we doing it? So you take first R1, R2, R, T1, Q and R you can do. Q and R, then T1, T2 and T. We will iterate through the loop and we'll see how this algorithm works. So initially R1 is equal to N, which is equal to 26, and R2 equal to B, that is 11. 11 mod 26 we have to calculate. Now, so you tell me what is the value of Q and R, and T1 is equal to 0, T2 equal to 1 initially. So what is Q and what is R?
So Q is 2.
And R is
So
4.
4.
4. 4. So what would be T? Apply the formula. T is equal to T1 minus Q T2. T1 minus Q T2. So this is minus 2. Fine. Now continue. So R2 will replace R1 and R will replace R2. Similarly, T2 will replace T1 and T will replace T2. So the copying the values 11, 4, and this is becoming 1 and minus 2. So now again you tell me what is Q and what is R?
Q is 2.
2 and 3.
2 and 3.
2 and 3. And what is T?
5.
5. Again, the same thing I repeat. So this is 4, this is 3, this is minus 2, and this is 5. So what is Q and R? 1 and 1. So what is T? T1 minus Q T2. So this is equal to minus 7. Right? T1 minus Q is 1 into T2. So this is minus 7. So to continue until R2 is equal to 0. Abhi tak hua nahi hai R2 equal to 0. So you have to continue 3, 1, 5 minus 7. So batao, what is Q and what is R?
3 and 0.
Sorry.
So 3 and 0.
3 and 0, and what is T?
26.
26. Note that whenever this remainder will be 0 ना, T ये मतलब एक चेक करने की रास्ता है कि आप कैलकुलेशन सही किया कि वो नहीं. T will become N, the modulus 26. Now you have to repeat again because R2 is still not 0, but it will be 0 in the next step. We can understand because R will come here. So this is 1, this is 0, and this is minus 7 and 26. Now R2 is equal to 0. Now once R2 is equal to 0, you have to check whether R1 is 1 or not. R1 is 1, that means we can have the multiplicative inverse of B with respect to N. Otherwise we could not have. Now T1 is the multiplicative inverse. Now what is T1? T1 is minus 7. So that means 11 inverse with respect to mod 26 is equal to kitna hua? -7. Now, -7 is not an element in Zn. -7 is not an element in Z26 because Z26 meaning you have to tell something between 0 and 25. So what is then -7?
19.
19 exactly, because you have remembered additive inverse. So -7 meaning the additive inverse of 7. 19 plus -7 matlab 26. 19 plus 7 is equal to 26. 19 plus 7 mod 26 is equal to 0. So 19 and 7 are the additive inverses of each other. So the final answer is 19. Now, how can you verify your answer is correct? We are saying 19, which is an element obviously in Z26, is the multiplicative inverse of 11. Check it. If you do 19 multiplied by 11, then you see the result is equal to 209. Correct? Now 209 mod 26. 209 को 26 से डिवाइड करो और देखो कितना रिमाइंडर आ रहा है. ये 8 से जाएगा. रिमाइंडर 1 आ रहा है.
Yes, sir.
Correct? So that means 11 into 19 mod 26 is equal to 1. 11 into 19 mod 26 is equal to 1. So that means 11 and 19 are the multiplicative inverses of each other. So this is the demonstration of the algorithm. This is called extended Euclid algorithm. Now this should have been discussed actually in your cryptography course. I don't know why not discussed so far. So that is the algorithm. Previously आप लोग सीखे थे कि कैसे मतलब क्या होता है multiplicative inverse, but what is the algorithm that I discussed? Now the same algorithm, exactly the same algorithm will be used to calculate the multiplicative inverse of a binary string also, or in other words, a characteristic polynomial. So apply the same algorithm in the same way that I have applied just now in this way, and then show me the calculations to calculate the multiplicative inverse of x square plus 1 with respect to x to the power 4 plus x. Achha, just 1 second. No, if I give this is actually from the book, then you will copy paste and then show me. You better do this thing. X cube plus 1. You calculate the multiplicative inverse of this with respect to the modulus polynomial is x to the power 4 plus x plus 1. This is also a prime polynomial of degree 4. You have to calculate x cube plus 1 multiplicative inverse of this with respect to x to the power 4 plus x plus 1. ये book से नहीं है, so you cannot copy paste. Use the extended Euclid algorithm. आप पहले इस question को copy कर लो. Then the algorithm is in front of you. You can see that algorithm. Make that table something similar to this and calculate. क्या क्या कॉलम रहना चाहिए ये भी यहाँ पे लिखा है, and this is the algorithm. Apply, calculate and tell me the answer. Even I do not know the answer because randomly I have given, not from the book. You will tell me the answer and then I will verify.
Sir, x to the power 4 plus 1.
What is the answer? X to the power 4 plus
1.
1. बाकी सबको करने दो, फिर देखते हैं.
Yes, sir.
Sir, x to the
Because I
power 4
also
plus
do
1.
not. Okay. I do not know the answer. I'll check. I am also calculating. अगर किसी को कुछ दूसरा आंसर आए तो बताना. x to the power 4 plus 1 किसने बताया? आपका नाम बताओ.
Sir,
किसका आ रहा है? ख्याति को आ रहा है. और किसको आ रहा है? सेम आंसर.
Supriya,
सुप्रिया
sir.
को आ रहा है. और किसको आ रहा है? ठीक है, देख रहे हैं. बाकी दूसरा अगर अलग कुछ आंसर हो तो आप बता सकते हो. सेम आंसर हो तो भी बता सकते हो.
सर x
एक्स आ रहा है. एक्स, खाली एक्स. क्या नाम है आपका?
यस सर विशाल
सर x आ रहा है इधर.
विशाल
विशाल.
यस सर.
दूसरा कुछ आंसर किसी को आ रहा है?
सर मेरा भी x आ रहा सर.
किसका नाम क्या है?
अंशुल.
अंशुल.
यस सर.
और कुछ?
Sir, x power 4 plus 1.
नाम क्या है आपका?
Anand.
हाँ, आनंद.
Sir, x to the power
x to the power
4 plus 1. Yes, sir.
नाम क्या है?
Yes, Himanshu, sir.
हिमांशु. और कुछ किसी को कोई आंसर? ओके, गुड. तो जिसने मनोहर x to the power 4 प्लस मतलब नाम तो आपको पता ही चल गया ना,
Yes, sir.
एक बुद्धि 4, इधर 4 और इधर 2, टोटल 6. They all are correct, but actually Vishal and Anshul are more correct than the other 4 because you have not done the reduction. Modulus is x to the power 4 plus x plus 1. You have got the correct answer x to the power 4 plus 1, but then you have to reduce it with respect to x to the power 4 plus x plus 1. And when you reduce it, the remainder is x, which is answered by Vishal and Anshul. Understood? Kathy, Supriya, Anand, and Himanshu?
Yes, sir.
Yes, sir.
Okay. So the final answer is x. And now you can check it. So, cross check kar lo. X into x cube plus 1 with respect to mod this. So it is easy to verify now. So this is x to the power 4 plus x with respect to x4 plus x plus 1 mod. So karo, divide karo, x to the power 4 plus x4, x to the power 4 plus x plus 1 से, तो 1 से जा रहा है, that is equal to x to the power 4 plus so x to the power 4 or x चला गया तो remainder is 1. Verified? They are the multiplicative inverses of each other. So ये हो गया, ठीक है? कैसे कैलकुलेट करना है multiplicative inverse of a string? Additive inverse तो हो ही गया था. तो मतलब we have defined a field z to power n z capital N is equal to 2 power n comma plus and multiplication. This is also a field, okay? String, binary strings, set of all n-bit binary strings, and we define the two operations. Now we'll learn that this multiplication, now addition operation is very easy. It is just bitwise OR, bitwise XOR, and I think you have little bit of knowledge, whatever be your background, computer science, IT or electronics. I think basic electronics, all of you have studied digital electronics. So you are already familiar with the gates, XOR gate, AND gate, NOT gate, NOR gate, etc., etc. And familiar with the registers, shift register, these things, basic architectures, computer architectures. So you know that it is very easy to design XOR between two 8-bit words or 16-bit words. And so just parallelly you have to connect 8 or 16 XOR gates. So it is meaning you can perform this addition operation very easily in the hardware also. Meaning to design the hardware. In the hardware you design a chip which takes 8-bit, this takes 8-bit input, and then it is the XOR operation, it produces 8-bit output. This chip is very easy to design. Now what about the multiplication operation? Can we design the same thing, a hardware chip which will perform the multiplication operation? It will take 8-bit data and produce the multiplication between the two. So definitely there will be some constant value, constant modulus polynomial stored inside it, or maybe we can take a third input, which is defining 9 bits definitely, which will be defining the modulus polynomial or modulus string. So is it easy to implement in software? Definitely you can do this thing coding because you have already learned how to implement these things, multiplication. But is it easy to implement in the hardware also? Or even if you implement it in software, is there any easier way to do the multiplication? That we'll see. Okay, alternative ways to do the multiplication. Multiplication already you have learned the basic definition, but I am saying, is there any easier way? Easier in the sense which is actually easier in implementation in hardware. Now I'll show that way. Suppose the same multiplication will perform. Suppose x to the अभी हमने क्या किए थे? X to the power 5 into x square plus x multiplied by x to the power 7, x to the power 4, 3, 2, x ये आपने किए थे है ना? अभी किए थे और जिसका आंसर आया था पहला जो मल्टीप्लिकेशन आज हम शुरू किए थे जिसका आंसर फाइनली आया था x to the power 4 plus 1. देखो इसको हम किस तरीके से कर सकते हैं और so you have to do x to the power 5 plus x square minutely observe करते रहो ठीक है x square plus x. This is the first operand and you have to perform x to the power 7 plus x to the power 4 plus 3 to x, x3 plus 2 plus x. And you have to do with respect to modulus polynomial x to the power 8 plus 4, 3, 1. This. Now see, इसको हम ऐसे भी लिख सकते हैं कि x to the power 5 into the whole polynomial plus x square into the whole polynomial plus x into the whole polynomial. This is the very basic definition. तो एक काम करते हैं इसको एक टेबल बनाओ जहां पे आप काम क्या कर रहे हो पहले राउंड में राउंड 1 में x से इसको मल्टीप्लाई करो x से मल्टीप्लाई कर रहे हो फर्स्ट राउंड में x से जब इसको मल्टीप्लाई करोगे सो व्हाट इज द रिजल्ट इसके लिए आपको पेपर पेन हाथ में लेना नहीं होगा आप मुंह से ही बता सकते हो if you multiply this polynomial by x then what would be the result?
x to the power 8 plus x to the power 5 plus x to the power 4 plus x.
मतलब क्या हो रहा है एक्चुअली पावर्स जो है एक एक करके बढ़ रहा है और कुछ नहीं जो पावर है इसका वो एक करके बढ़ा रहे हो so this is becoming x to the power 8 plus x to the power 5 plus x to the power 4 plus x to the power 3 plus x square. Fine, no problem. Now this requires reduction or not? Requires reduction का मतलब क्या है और not का मतलब क्या है कि you are handling 8-bit words, so the maximum power of x can be 7. If the result is coming in crossing x to the power 7, it is going to x to the power 8, then you have to reduce it with respect to this polynomial. So this result x into this polynomial requires reduction or not?
Yes, sir.
It requires reduction. That means now the next step is that you have to calculate this mod this, meaning इसको इससे डिवाइड करने के बाद रिमाइंडर क्या आएगा वो आपको यहाँ पे लिखना होगा आफ्टर रिडक्शन. तो आप अपना बुद्धि इस्तेमाल करो बट पेन इस्तेमाल मत करो. डोंट यूज द पेन, यूज योर टैलेंट एंड देन टेल मी व्हाट वुड बी द रिमाइंडर.
X power 5.
5 x to the power 5 plus x square. No, no.
X square.
X to the power 5 plus x.
बोलो बोलो x to the power 5 plus
X.
Plus
x
1.
Yes, sir.
X
Plus
to the
1.
power 5 plus
Plus
x
1.
plus 1.
x to the power 5 plus x plus 1.
Yes,
X
sir.
to the power x square plus x plus 1.
Sir, x
x
to
to
the
the
power
power
Oh,
x
yeah.
to the
square
power 5 plus x square plus x plus 1. देखो इसमें क्या होगा जब आप इसको इससे डिवाइड करोगे, यहाँ पे जो रहेगा उसका मैक्सिमम पावर कितना हो सकता है? 8 से ज्यादा तो नहीं हो सकता है ना, क्योंकि यहाँ पे जो दिया गया है आपको उसका मैक्सिमम पावर 7 हो सकता है, 7 से ज्यादा नहीं होगा। तो उसको जब आप x से मल्टीप्लाई करोगे तो मैक्सिमम पावर 8 ही हो सकता है, 8 से ज्यादा नहीं होगा। तो इसको जब आप इससे डिवाइड करोगे तो कोसेंट में तो 1 ही आएगा ऑलवेज। कोसेंट में 1 के सिवा और कुछ नहीं आ सकता। लिख के दिखाऊं मैं क्या कह रहा हूं कि यहाँ पे जिसको आप डिवाइड कर रहे हो x to the power 8 उसका मैक्सिमम पावर है प्लस 5 प्लस 4 प्लस x क्यूब प्लस x स्क्वायर, और जिससे डिवाइड कर रहे हो उसका भी मैक्सिमम पावर 8 ही है। मॉड्यूलस जो है उसका मैक्सिमम पावर, उसके साथ में क्या क्या है दैट इज नॉट इम्पोर्टेंट, लेकिन उसका मैक्सिमम पावर 1 है, 8 है। तो यहाँ पे कोसेंट पे 1 ही आएगा ऑलवेज, 1 के अलावा और कुछ नहीं आ सकता है। अब यहाँ पे अगर 1 आ गया तो यहाँ पे क्या आएगा? यहाँ पे एक्चुअली इसी को कॉपी पेस्ट करना होगा मुझे, मतलब यहाँ पे जो लिखा है वही चीज यहाँ पे मुझे कॉपी पेस्ट करना हो रहा है। अब क्या होगा? माइनस का मतलब क्या? सिमिलर टर्म कट हो जाएगा, बाकी जो बचा दैट वुड बी द रिजल्ट। तो इसको हम डायरेक्टली कर सकते हैं। मतलब क्या हुआ? जो डिविडेंड, दिस वाज एक्चुअली द डिविडेंड एंड दिस वाज एक्चुअली द डिवीजर, सो दोनों को आप जोड़ कर दिए और जो बचा दैट इज द रिजल्ट। सो वो डायरेक्टली यहां से भी हो सकता है, मतलब इसको और इसको आप जोड़ करो, एक्सोर करो, तो जो जो सिमिलर टर्म्स हो गया वो कट गया और बचे जो बचा वो रिजल्ट। सो दिस इज x to the power 5 plus x square plus x plus 1. So this is the result of multiplying this polynomial by x. Now next step, now we'll multiply this same polynomial by x square. We want to multiply the same polynomial by x square. ठीक है, next step में। Now you can understand in the next step will be willing क्यों मैं मैक्सिमम 5 तक गया, क्योंकि यहाँ पे मैक्सिमम 5 है, जो फर्स्ट ऑपरेंड है वहां पे x to the power 5 मैक्सिमम है। ठीक है, सो ये सब बाद में आएंगे हम। इसको देखो, we want the result of x square multiplied by this. Now x square का मतलब क्या है? x into x, मतलब this multiplied by x multiplied by x. Now this multiplied by x, already we have got the result. So x square into this, matlab just you have to multiply this quantity by x, right? Now that is again the same thing, you have to just increase the powers by 1. So the result is x to the power 6 plus x 3 plus x square plus x. Right? Now tell me, does it require reduction?
No, sir.
No. So this is the final answer. No reduction required. Now tell me what would be the result of, पहले रिडक्शन करने के पहले वो क्या आएगा वही बताओ। रिडक्शन चाहिए कि नहीं चाहिए वो हम बाद में देखेंगे। जस्ट सिंपल रिजल्ट बताओ। x cube into this polynomial, what would be the result?
Sir, x to the power 7.
इसको x से मल्टीप्लाई करना होगा क्योंकि x into x square x cube. So this will be x to the power 7 plus x to the power 4 plus x cube plus x square. Does it require reduction?
No, sir.
No. Again the same thing I repeat. So again increase x to the power 8 plus x 5 plus x4 plus x3. Does it require reduction?
Yes, sir.
Yes, sir.
Then what would be the result after reduction?
X to the power of 5 plus x plus 1.
Right. The same thing. X to the power 5 plus x plus 1. Again, continue. So x multiplied by this, so increase the powers. X to the power 6 plus x square plus x. It does not require reduction. So ये सब हम कर लिए. अब पहले क्या बताए थे कि this into this is nothing but x into this plus x square into this plus x to the power 5 into this. Now that means you need which result? X into this. That means you need this result plus x square into this. That means you need this result plus x to the power 5. So you have to add this plus this plus this. So add the three terms and then tell me the final result. Remember, plus meaning similar terms will cut. So क्या क्या बच रहा है?
X to the power of 5 plus x cube
Yeah.
plus x square plus x plus 1.
X to the power 5 plus x cube plus x square plus x plus 1. This is the correct answer. What is your name?
Supriya, sir.
Supriya. So you can verify previously you multiplied it directly, the same result you have got. Okay, this way you can get the same result. Now let us observe. So all of you have understood this technique. Now let us analyze what is the advantage in this technique. What are the advantages? See the steps. So iterating, you are doing iterations. How many number of iterations are required? You have to see the maximum power of the first operand. Okay, meaning you can interchange it, but if I consider this as the first operand, then you have to go up to how many iterations? The maximum power of that first operand. Then in each iteration, what are you doing? What are the operations you are performing? Specifically from the point of view, we are analyzing that how easy the steps are to implement it in hardware. So here, what are you doing? You are increasing the power of a characteristic polynomial by 1, meaning each term by 1. So if I assume this is a binary string, then what exactly I am doing? Meaning how can we implement it using a hardware? You tell me. Basic knowledge about hardware, all of you have. Register, gate, weight, etc. All of you know. How can I perform this operation? That I have to increase. This corresponds to a binary string. Definitely in hardware, you cannot put a characteristic polynomial. In hardware, you have to put the binary string.
Left
Now,
shift of the bits.
Left shift of the bits. See the difference between this polynomial and this polynomial, and if you convert this in binary and you convert this in binary, then the difference is only that 1 bit the content has been shifted. So you need a left shift register, easily available in the market, meaning very cheap left shift register, basic operation, basic hardware. So you need 1 bit left shifting, which can be easily implemented in hardware. 1 bit लेफ्ट शिफ्ट आपने कर लिए. और क्या चाहिए आपको? रिडक्शन. एडिशनली कुछ स्टेप में आपको रिडक्शन लग रहा है. तो रिडक्शन क्या हो रहा है एक्चुअली हार्डवेयर में? उसका इक्विवेलेंट क्या हो रहा है एक्चुअली? नथिंग. एक्सओर करो, पहले मैं बता ही दिया हूं. सो दैट रिक्वायर्स एन एक्सओर. सो ओनली लेफ्ट शिफ्ट रजिस्टर एंड एक्सओर. With the help of left shift register and some XOR gates, we can perform this multiplication, binary multiplication in hardware very easily and with very cheap hardware device. We do not need any complicated hardware device. So that means like addition, you can also perform the multiplication, binary multiplication binary string multiplication. Remember, this is not integer multiplication in binary format. This is binary to binary multiplication in the hardware. So every step you need one left shifting. After one left shifting, one bit left shifting, how do you decide whether that content require a reduction or not?
So by checking the power of the maximum power of the
MSB position. MSB position you will check. MSB position, if it is 1, definitely the content size will be 9 bits. 9th bit. If it is 1, then you need to have a reduction. X to the power 8 meaning this is the 9th bit. Na? So 9th bit, if it is 1, then you need reduction. Otherwise, you do not need reduction. So अगर आप समझ गए हो, देखो आपको मैं दिखा रहा हूँ किताब से, डायरेक्टली किताब से आपको दिखा रहा हूँ. दिस इज फ्रोजन. अब पीपीटी नहीं है सामने, ये दिख रहा है आपको. सो the same thing they have done. They have converted P1 into binary, P2 into binary, and this the modulus polynomial. This is 9 bits into binary. Then what are you doing? Every iteration you are doing 1 bit left shift, and whenever after left shifting the 8th bit will become 9th bit will become 1, you need to XOR with the polynomial. यहाँ 9th बिट उसने दिखाया नहीं, 9th बिट 1 था, ठीक है, क्योंकि ये 8 बिट में ही दिखाया है, तो बाकी 8 बिट के साथ 8 बिट का XOR हो रहा है, whatever the reason. Now you have understood this thing, then I will give you another exercise which is not from book. First tell me you have understood this mechanism or not. You have to do it in this mechanism only. You cannot apply that mechanism and then show me. Send the photo and in the mail I'll give you one exercise. If आप समझे नहीं हो तो आप पूछो पहले कि नहीं मैं समझा नहीं. Modulus polynomial, let it be remain the same. Okay, जो यहाँ पे आप कॉपी भी कर सकते हो. Modulus polynomial will remain the same. 1 0 0 0 1 1 0 1 0. I repeat again, 1 0 0 1 1 0 1 0. 9 bits. 9 bits.
So please repeat.
1 0 0. This is actually the thing. 1 0 0 1 1 0 1 0. Total 9 bits are there. 1 0 0 1 1 0 1 0. So
Okay,
this
sir.
modulus will remain the same, but the operands I am randomly telling you. So the first operand, suppose 1 1 0 1 लिखो, मैं बता रहा हूँ 1 1 0 1 यहाँ पे भी दे सकते. This is suppose first operand P1 and the second operand is yeah 0 1 0 1 0 1 0 1. अब बताओ this multiplied by this with respect to this modulus this क्या रिजल्ट होगा ये बताओ. उसी तरीके से आपको टेबल बना के कैलकुलेट करना है एंड फोटो खींचो और मेल करो. First operand is 1 1 0 1 0 1 0 1. Second operand is 0 1 0 1 0 1 0 1. I am also trying. You also try. आप चाहे इसको फास्ट ऑपरेंट कर सकते हो, इसको फास्ट ऑपरेंट कर सकते हो. दैट इज अप टू यू बिकॉज इट इज कम्यूटेटिव. द सेम रिजल्ट शुड कम.
जी है ठीक है। 1 2 3 जी है ठीक है। खाली रह रहा है। Multiple 0 double 0 1 0 1 1
बहुत बड़ा हो रहा है सर नहीं। अच्छा, एक एक करके बताओ, आप लोग मैक्सिमम किसको फर्स्ट ऑपरेंड लिए? इसको फर्स्ट P1 को या फिर P2 को? किसको फर्स्ट ऑपरेंड लिए?
P1 को।
P1 को ही फर्स्ट ऑपरेंड लिए?
P2
Yes,
सर,
sir.
Yes, sir.
P2 को सर।
P2 को ले।
P2 को लेना चाहिए था क्योंकि P2 में
So P2.
कम है, पावर कम तक जाना चाहिए ना। यहाँ जाओगे तो 8 तक करना होगा आपको। साधारण बुद्धि क्या कह रहा है कि आप अगर यहाँ तक जाओगे तो आपको एक काम करना होगा। तो इसको अगर आप पहला ऑपरेंड लिए हो तो आप स्टेप्स में बताओ कि सेकंड मैंने जीरो स्टेप में तो वही है, मतलब जीरो स्टेप में क्या आ रहा है? मतलब आप फास्ट स्टेप में जीरो कहो चाहिए फास्ट स्टेप कहो, जो भी कहो, क्या आ रहा है आपको? जीरो स्टेप में तो ये इटसेल्फ है, इसके बाद क्या
P1
आ रहा है? तो उसके बाद क्या आ रहा है?
10110000.
10110000, करेक्ट। उसके बाद क्या है?
011111010.
011111010, राइट। उसके बाद
तो सर सेम ही आ जाएगा।
again the same thing sir.
सेम का मतलब?
सर कोई
Same
रिडक्शन
zero.
नहीं चाहिए होगा।
Yes sir.
ना ना, क्या आ रहा है वो बोलो, स्ट्रिंग को बताओ।
सर तो 3 4 5 6 7 8 0 0 1 1 1 1 0 1 0।
कैसे हो रहा है ये?
क्या सर?
मतलब ये कैसे आया ये? इसका प्रीवियस स्टेप में आया था 0 4 1 है, मतलब 0 1 1 1 1, उसके बाद 0 1 0 है ना, इसका प्रीवियस स्टेप में था। तो इसको आप लेफ्ट शिफ्ट एक घर कर रहे हो तो क्या आ रहा है?
हाँ सर, हाँ
One.
एक, हाँ यस सर, लास्ट में एक 0 अपेंड हो जाएगा।
11110100 sir.
11110100, इसका कोई रिडक्शन चाहिए कि नहीं चाहिए?
No sir.
नो सर।
नहीं चाहिए, क्योंकि यह 8 बिट है, 9th बिट, मतलब 9th बिट इसका 0 रहा।
Yes sir.
ठीक है, अभी मैं पूरा नहीं कर रहा हूँ क्योंकि इसमें बहुत टाइम लग जाएगा। ऐसे कर करके आपको 5 तक जाना है। 5 तक जाने के बाद कौन कौन सा जोर करोगे? कौन कौन सा पोजीशन जोर करोगे? जो जहां पे यहाँ पे 1 है, ठीक है, P2 पे 1 है, मतलब इस पोजीशन को आप 0 माने हो तो ये 0th पोजीशन, या फिर अगर आप इसको फर्स्ट पोजीशन माने हो तो फर्स्ट पोजीशन वाला, फिर थर्ड पोजीशन वाला, 7th। ये सब में जो जो रिजल्ट आया उन सभी को आपको XOR कर देना है, तो फाइनल रिजल्ट आपको मिल जाएगा। अभी नहीं हुआ, देखेंगे हम C3 में ऐसा एक रिव्यू टेस्ट में एक एग्जाम क्वेश्चन ऐसा दे देंगे। तो एक क्वेश्चन करते करते आपका पूरा C2 रिव्यू टेस्ट, C3 रिव्यू टेस्ट खत्म। एक ही क्वेश्चन रहेगा 40। तो दिस इज द थिंग, ओके। तो अभी प्रैक्टिकल बातें करते हैं, मतलब हमको क्यों चाहिए था ये हार्डवेयर इम्प्लीमेंटेशन, इतना क्यों किया हमने, ये हम बता रहे हैं। इसका पर्पस क्या है एक्चुअली? पहले ही हम आपको बता चुके हैं कि डेटा एन्क्रिप्शन एक्चुअली सिमेट्रिक क्रिप्टोग्राफी से होता है, पब्लिक क्रिप्टोग्राफी से डेटा एन्क्रिप्शन नहीं होता है। तो पब्लिक की क्रिप्टोग्राफी किस काम पे आता है, किसको याद है आप बताओ? जिसको भी याद है वो बताओ। पब्लिक की क्रिप्टोग्राफी बेसिकली देन कहाँ पे यूज होता है?
फ्री ट्रांजैक्शन में।
इसके लिए
फ्री ट्रांजैक्शन में की को ट्रांसफर करने के लिए।
क्या होता है, मैं क्लियरली सुन नहीं पाया।
सर सिमेट्री की को ट्रांसफर करने के लिए।
हाँ, सिमेट्री की मतलब एक जो कम्युनिकेट हो रहा है एंटिटी A और B के बीच में जो कम्युनिकेशन हो रहा है, सभी डेटा पैकेट जो ये इसको भेज रहा है या फिर सभी डेटा पैकेट जो ये इसको भेज रहा है, all will be encrypted using symmetric key K. This is the plain text and this is the ciphertext, and this will be decrypted using the same key K. Symmetric encryption use होता है, लेकिन ये की कैसे established होगा? The key will be established with the help of public key cryptography between A and B. Now the question is, what type of दो क्वेश्चन है, टू क्वेश्चन है देयर. व्हाट टाइप ऑफ symmetric cryptography again of two types. I think it has been discussed. Block cipher and stream cipher, जो भी हो, चाहे वो ब्लॉक साइफर हो या फिर स्ट्रीम साइफर हो, यूजुअली क्या होता है कि लार्ज वॉल्यूम ऑफ डेटा जब आप कम्युनिकेट कर रहे हो, ये जो हम कम्युनिकेट कर रहे हैं ना, अभी हम क्लास ले रहे हैं, तो कितना वॉल्यूम ऑफ डेटा जा रहा है, वॉइस, ऑडियो, वीडियो, कितना भी कुछ जा रहा है, या फिर आप जब कुछ भी देखते हो तो लार्ज वॉल्यूम ऑफ डेटा एनक्रिप्टेड होके, एनक्रिप्शन डिक्रिप्शन, इधर से एनक्रिप्शन हो रहा है, आपके मशीन में डिक्रिप्शन हो रहा है, ह्यूज अमाउंट ऑफ डेटा एनक्रिप्शन डिक्रिप्शन होता है. तो क्या है कि जो हार्डवेयर मतलब कंप्यूटर है, बड़ा कंप्यूटर है, डेस्कटॉप कंप्यूटर, लैपटॉप, इसमें कोई प्रॉब्लम नहीं है. लेकिन क्या है कि जब ये ह्यूज वॉल्यूम ऑफ डेटा एनक्रिप्शन डिक्रिप्शन होना पड़ता है छोटे डिवाइस में, जैसे मोबाइल फोन में, सेंसर नोड में, जो रिसोर्स कंस्ट्रेंट है, वहां पे अगर ये एनक्रिप्शन एंड डिक्रिप्शन सॉफ्टवेयर में करना पड़ा, ओके, सो आई गॉट डिस्कनेक्टेड. तो जो मैं बता रहा था कि हार्डवेयर पे जब करना है, मतलब यहाँ तक कहाँ तक सुने थे आपने? यहाँ तक सुने थे ना कि, अच्छा ये कहाँ गया? तो यहाँ तक आपने सुने थे कि इसको अगर हार्डवेयर पे, इसको अगर छोटे हैंडहेल्ड डिवाइस में, मोबाइल, जैसे कि पुराने जमाने का कम्युनिकेशन, पुराने नहीं, आज के जमाने में भी जो मोबाइल कम्युनिकेशन होता है, देखो मोबाइल फोन पे आजकल, मोबाइल फोन मतलब सभी मोबाइल फोन स्मार्टफोन है, मिनिमम 3G है, 4G तो है ही, मतलब. तो यहाँ दो टाइप ऑफ कम्युनिकेशन होता है. हेलो मनोहर, कैन यू हियर मी?
Yes, sir.
Yes, sir, you are audible, sir.
हाँ, सो दो टाइप ऑफ कम्युनिकेशन होता है. एक तो जीएसएम कम्युनिकेशन, जो पुराने जमाने में भी होता था, आज के जमाने में भी होता है, जो मतलब आप जब किसी को कॉल करते हो, व्हाट्सएप कॉल नहीं, नॉर्मल मोबाइल कॉल जो करते हो, या फिर एसएमएस भेजते हो, व्हाट्सएप मैसेज नहीं, तो वो होता है नॉर्मल जीएसएम कम्युनिकेशन. और दूसरा होता है आपका जो इंटरनेट, जीपीआरएस कम्युनिकेशन जिसको कहते हैं. मतलब उसी नेटवर्क को जीएसएम को यूज करके उसमें डेटा पैकेट फॉरवर्डिंग बाद में चालू हुआ, जब आपको ये सब आप लोगों को पता होगा 2G 3G ये सब चीजें। तो पुराने जमाने का बात कर रहा हूँ मैं, मतलब जो अभी भी यूज होता है वॉइस कॉल के लिए, नॉर्मल वॉइस कॉल के लिए। तो क्या होता था या फिर होता है, जो आप कम्युनिकेट कर रहे हो आपका मोबाइल फोन से लेके टावर तक, जो टावर के साथ जो कम्युनिकेशन होता है वो एनक्रिप्टेड होता है, ठीक है, बाई डायरेक्शनली वो एनक्रिप्टेड रहता है। तो पूरा डेटा स्ट्रीम जो है वो एनक्रिप्टेड जाता है टावर तक। तो ये एनक्रिप्शन किस टाइप ऑफ एनक्रिप्शन होता है? सिमेट्रिक एनक्रिप्शन होता है। एंड दिस सिमेट्रिक एनक्रिप्शन इज डन एट द हार्डवेयर। द मोबाइल कंटेन्स अ चिप टू परफॉर्म दीज सिमेट्रिक एनक्रिप्शंस, ठीक है। तो वो सिमेट्रिक एनक्रिप्शन एक की एस्टेब्लिश्ड, जो ये हैंडशेकिंग मैकेनिज्म चलता है, हैंडशेकिंग होता है टावर के साथ मोबाइल फोन का, तो एक सिमेट्रिक की एस्टेब्लिश्ड हो जाता है ऑटोमेटिकली। एंड तब आपका एनक्रिप्टेड होता है डेटा हार्डवेयर पे। सो दिस इज द पर्पस एक्चुअली, कि जब हम यूज वॉल्यूम ऑफ डेटा को एनक्रिप्ट करते हैं, यूजुअली ऑल हार्डवेयर्स provide some encryption mechanism, so you do not need to implement those things in the software. So all of you have understood what is the purpose, कि क्यों हमको हार्डवेयर पे ही इंप्लीमेंट करना चाहिए सिमेट्रिक एनक्रिप्शन को, खास करके पब्लिक की क्रिप्टोग्राफी यू कैन इंप्लीमेंट इन सॉफ्टवेयर, बट सिमेट्रिक एनक्रिप्शन जो भी एल्गोरिथम आप लिखो, चाहे वो ब्लॉक साइफर हो, स्ट्रीम साइफर हो, that should be implementable in the hardware easily. You can use software also, no problem, but this should be easily implementable in hardware. Now आपने DES और AES आप लोगों को पढ़ाया गया था, मतलब प्रतीक ने डिस्कस किया था, उसमें मैं एक बार रिव्यू कर देता हूँ DES और AES क्या है। अच्छा, मैं आ रहा हूँ, 1 मिनट बाद ब्रेक ले लो थोड़ा। Hello, Manohar. Hello.
Yes.
So just a little bit for discussion. So I was saying that I'll show you the, again, I'll revise the concepts of, basic concepts of DS and AES, although it has been discussed by Pratik. Manohar, can you see the PDF?
Yes, sir.
Yeah. So this is the basic structure of DES. I think these should have been discussed, will be discussed in the cryptography class also. So in brief, I'm just mentioning. So this is the general structure of DES. So you take 64-bit plain text and a 64-bit ciphertext key. Here it is showing 56-bit ciphertext key, but actually you can see this diagram. So this is the key generation function. So key generation function, it takes actually originally 64 bits input, and then after parity drop, some bits are used for error correction, parity codes. After parity drop, it becomes 56 bits. So otherwise, originally 64 bits, the size of the key for DES. So 64 bits key and 64 bits plain text. Then it goes through several rounds, usually 16 rounds, and which is preceded and followed by 2 permutations. So you are already familiar with permutation, just permutating the bits. So there is nothing to explain the permutation or substitution. So or left shifting, very easy operations. And each round takes the output of the previous round and a key. So 16 rounds, 16 keys are generated. Each key is again 48 bits long, and all the keys are generated using a function called round key generator, which takes the original key after parity bit reduction. It is 56 bits. So it is given as the input to the round key generator, which generates the round keys. Now, what happens inside each round? So if we look into the box, each round is same. So what happens inside each round? This is the round. So in this round, what is happening? Basically, you see 3 operations are getting performed. One is the swap. This last one is a swap. Left side and right side of the byte you are swapping. Second is XOR, XOR operation, bitwise XOR, and the third one is F, a function. What is happening inside this F? So this is the picture inside that F. 3 things are operating. First is expansion. Expansion box also I think already have been discussed, so there is nothing to explain. And straight P box. Straight P box is just a permutation box, so the bits are permutated, and then we mix the key bits using bitwise XOR operation. And there are some S boxes. This S box, each S box is a substitution box. So क्या होता है कि इसमें we have tables. Okay, so when these 48 bits are divided into 1, 2, 3, 4, 5, 6, 7, 8 parts. So that means each part is of 6 bits. 8 into 6 is 48. So each box taking 6 bits input, and you can see total 32 bits output. So each box is producing 4 bits output. 4 into 8 is 32. So that means each box takes 6 bits input and produces 4 bits output. How that is performed? Actually, we have a table that is not shown here. It will be shown here in the book. So ऐसे होता है कि एक so 6 bits input, 1, 2, 3, 4, 5, 6. 6 bits input meaning how many possible inputs are there? 64. And 4 bits output meaning what? How many possible outputs are there? 16. Am I right? So what happens? We have a table. This table is of 4 rows we have, and then 16 columns. Okay, so there are 4 rows and there are 16 columns. Okay, we take the first bit and the last bit. So 2 bits will decide the row. 2 bits, 4 possible values will decide the row, and the middle 4 bits will produce 16 possible values, will select the column. So uniquely you are identifying 1 row and 1 column. So that cell, that particular cell, each cell is containing a value, 4 bits value. So that is retrieved and returned. So in place of this 6 bits value, you are getting that 4 bits value. So this is the basic concept of these S boxes. So this is called substitution box. There is nothing. So the same thing is repeated in the reverse order during decryption. Okay, and the key generation function, round keys are generated, 16 round, 16 keys are generated from the original key after parity drop. What is happening inside this? Inside this, basically two types of operations are happening. One is the left shift operation and another is the compression function. Compression, I think you have already studied. What is a compression thing? So this is the basic architecture of DES algorithm. Anybody having any question? I'm not discussing in the detail because this is part of cryptography. I'm just giving you one overview that basically what happens inside DES, the basic operations are XOR, bitwise XOR, and then state permutations or left shifting or sometimes compression and substitution. Substitution is that type of thing where we have a set of tables. The table stores some constant values, and then depending on the input, you retrieve from the, you look up into the table and then get one value, give us the output. Any question on DES? And remember that DES is called a Feistel cipher structure in which we do not have any, we use non-invertible components. Non-invertible component meaning one component for which you do not have the inverse function. For example, if we have a compression function, then that is non-invertible. Once you generate 32 bits output from a 42 bits, 48 bits input, that means some information you were losing. You can never get back that information. So that's why this is non-invertible. Okay. And since we're using non-invertible input, so during decryption, you cannot use the inverse of any component used during encryption. So what you have to do, we generate the same thing. You can see the DES and the encryption and decryption algorithms, they use the same function f as it has been shown here. So the same function f is generated, not f inverse. And that is a big difference between DES and AES. AES is a Feistel cipher structure where we use invertible components only. Non-invertible components are not allowed. So in AES, this is the basic structure of AES. We have several rounds. We take 128 bits plain text, produce the same size ciphertext. However, the key size depends on version. We have AES 128 bits version, 192 version, or 256 bits version. And depending on the key size, we decide the number of rounds. For example, for 128 bits key size, we use 10 rounds. 192 bits key size, we use 12 rounds. And so unlike DES, where the number of rounds is fixed, 16, here the number of rounds can be 10, 12, or 14, depending on the key size. So the same thing here also, we have some initial permutation. After that, we have several rounds. And then we have a key generator, key expansion function, which takes the original key, ciphertext key, and generates the round keys. Now we'll look into the inside of the round functions and key expansion function, what happens in each round. And so what happens in each round, you see 128 bits meaning actually 16 bytes. 16 bytes is represented in a matrix format, in a 4x4 matrix format. 4 into 4 is 16. Then what happens? So you see every round is taking 128 bits input from this side and 128 bits from this side, meaning from the previous stage output and one round key. So two matrices, 4x4 matrices are given as the inputs to the round, to the rounds. Just a second. Two matrices are given as the. So this is one round, and inside one round, 4 functions basically happen: sub byte, substitute byte, shift rows, mixed column, and add round key. Add round key is nothing but XOR operation, bitwise XOR operation. Substitute byte is similar to that substitution function which I explained for DES. It substitutes the bytes looking into some pre-existing tables. Shift row is very easy, shifting left shift or right shift. Mixed column is nothing but multiplication, matrix multiplication, one row cross one matrix. So substitution box, as I said, that you give one matrix and there is a table. So each entry in that matrix, we look into the table and we get a replacement value. So corresponding to every table, there is an inverse table. So inverse table meaning when you give this as the input, then you can get this as the output. As I said that the components are invertible. So this is one example of a substitution table in AES. As you can see, there are 16 rows and 16 columns also. It has been broken into 2 slides. So 16 rows and 16 columns, so 16 into 16, 256 entries are there, because 256 meaning 8 bits. Okay, 1 byte. Each cell of this matrix is 1 byte. As I said that for 16 bytes input, 128 bits input. And then left shift is very easy. Left shift, and the mixed column is nothing but we have a constant matrix, and then each row is multiplied with that constant matrix to get the result, and that replaces the original column. Okay. And if we have a constant matrix, then we have a inverse constant matrix also. That means when we multiply this row with the constant matrix, we get this result. And then if we multiply this row with the inverse constant matrix, then we'll get back this row, original row as the again, because we need invertible components in AES, the difference with DS. Okay. So this is all about AES. So what we have observed that both AES and DES you can easily implement in hardware. But a DES is easier to implement in hardware because the size of the tables are smaller. However, AES, you can use tables, but those will be bigger, larger, or alternatively, those tables can be generated using some formula also. But in that case, the computation cost will increase. I am not discussing in details. I am just giving you a fast forward view of the things, because the things will be discussed in detail in the cryptography course. So this is all about 2 types of block ciphers. So block cipher, and the original concept of block cipher, you already are aware about that. It takes the data as a block of n bits plain text, and then a chunk of data, and then encrypts with the key. But in stream cipher, there is another mode of symmetric cryptography, which is called a stream cipher. In stream cipher, what happens? The data comes bit by bit, bitwise the data comes, and key bits are also generated bit by bit from the original key. You can have 128 bits key or 256 or 64 bits key. From that, a stream, millions of bits are generated using a pseudo-random number generator, pseudo-random key generator, that to say, and then bitwise XOR are done. That means what happens, what I'm saying is, plain text. This is the plain text. Plain text is broken into stream of bits. And either we have a key generator which takes the original key and then produces again a pseudo-random sequence of bits. And then we do bitwise XOR and produce a sequence of bits, which is the ciphertext. This is the simple concept. So we do not take the plain text as a chunk of data. We view it as a stream of bits, and then bitwise XOR that stream of bit with another bit string, which is generated by a pseudo-random number generator, which takes the key as the input. And then finally, we do the bitwise XOR between the 2 streams, and that stream is the ciphertext stream. Now, a popular, how do you generate this? How would you design this key stream generator? That is the algorithm, stream cipher algorithm, and most popular stream cipher algorithm is known as RC4 algorithm. In RC4, what do we do? In RC4, we have a state box. Something is called an array, just a 256 element array. And each element is initialized with the successive values 0, 1, 2 up to 255. Now then we mix, we take another array, key array, in which we keep the original key, maybe 128 bits, 256 bits, but we repetitively repeat the key and then fill this key array. Then we mix the two arrays so that we get an initial permutation in the box. After getting the initial permutation in the box, what do? Every round we do some shuffling, like we shuffle the cards in a pack of cards. So we shuffle the elements, we just swap the elements randomly. So there is a pseudo random, you can see the algorithm is available everywhere. RC4 algorithm, if you search at the Google, 4 lines or 5 lines codes in software, in C easily you can code it. So this is the algorithm to do this thing. Easily you can learn by yourself, analyze by yourself also. So the main concept in the algorithm is the swap. So we swap the ith element and jth element of that array, which is called the state box. But what would be the value of I and j that is decided using some pseudo random generation. These are the codes to generate the successive values of I and j. So that means simply saying each round what we do, we shuffle the box by not substituting, swapping two elements, two randomly selected elements. And then like what is happening, every round you are shuffling the pack of cards and then telling someone that draw a card randomly. So, and then show it as the output. So that is happening here. And so the last line in this algorithm, this one is actually getting the output from that state box. Getting a random element, you see Si plus Sj again is a random value, and that indicates the index in the array. We take a random element from that array state box, and that is given as the output. Since the elements can be anything from 0 to 255, that means you can represent it using 8 bits. So every round it produces 8 bits of output every round. Now you repeat until your data is entirely encrypted. So this is all about stream cipher. You can, I'm not discussing because these things will be discussed in the cryptography course. Another thing is regarding the block cipher, important thing is that as you have seen any block cipher, it can handle a maximum size of data. For example, DES can handle 64 bits or AES can handle 128 bits. But your data file may be much larger than that. It can be 1 kilobyte, 1 megabyte, 1 gigabyte. Then in that case, what would you do? The simplest way, you can then encrypt it repetitively, but in different ways. For example, the simplest way is called electronic code book mode, ECB mode. There are 5 or 6 modes actually of doing block cipher. ECB mode is this thing. Parallelly, you just break the data in multiple pieces, each one of 128 bits, and then parallelly encrypt all using the same key. But there are other ways also. For example, you can take the feedback from the previous stage and then mix it with the current stage data. Mixing meaning XOR, XY, bitwise XOR, XOR operation, and then encrypt it. So that type of mode is called cipher blockchaining mode, CBC mode. So there are actually 5 or 6 modes. Exactly, I do not remember 5 or 6. ECB mode, CBC mode, CFB mode. CBC meaning cipher blockchaining mode, CFB meaning cipher feedback mode. CTR mode is there, counter mode, OFB mode is there, output feedback mode. I think these are the 5 modes of operation in which now each mode definitely will have its own advantage and disadvantages that will be discussed in the cryptography class. So in brief, symmetric cryptography are of 2 types, block cipher and stream cipher. Most well-known block cipher algorithms are DES and AES. And most well-known stream cipher algorithm is RC4. All of you who are studying specifically CLI specialization, you must have to have the basic knowledge of DES, AES, and RC4 algorithm. And then I discussed different modes of block cipher, because why the modes are required? Because you cannot handle more than 128 bits or 64 bits of data in one go in block cipher. So in order to, but for stream cipher, there is no problem. As I said, that you repeat the same process rounds. Every round you will generate 8 bits of key stream. And then you repeat until the entire data file is encrypted. But for block cipher, you take the data as a chunk, and the chunk size may not be or cannot be larger than 120 bits for AES and it cannot be larger than 64 bits for DS. So then how do you perform encryption of large file? For that, we have 5 modes of operation. The simplest one is known as ECB mode, electronic code book mode, where you just break the data into multiple pieces and encrypt each piece separately, independently, parallelly with the same key. However, that is not completely secure. I mean, you can achieve more security to feedback the previous stage output with the next stage, and that feedbacking can be done in different ways. And depending on that, CFB mode is there, OP mode is there, CTR mode is there, CVC mode is there. Those modes will be discussed. That is all about symmetric cryptography, symmetric key cryptography. So in all the operations you have seen, we need to add 2 binary strings. In some places, we need to multiply 2 binary strings. Each binary string may be of 1 byte, usually 1 byte, maybe larger than that also. So that's why we first defined a mathematical field, and we defined the operations in mathematics, and also we defined the operations in hardware. Okay, this is all about the briefing of symmetric key cryptography. Public key cryptography, I think Pratik has already discussed RSA, and I have already discussed the discrete log problem. Am I right? Pratik has discussed RSA, right?
Yes, sir.
Yeah, but he has not discussed, I think, Diffie-Hellman algorithm. Am I right? Has he discussed Diffie-Hellman and
No,
elliptic
sir.
cryptography? See, again, I am just giving the briefs of cryptography. See, the rest of the syllabus of network security, now I have already in my website. You can find my videos. My TAs have created in the previous years. Those are very easy to understand. There is nothing in network security, nothing difficult in network security. Only the difficult thing is in the cryptographic concept. So I am giving you the brief ideas about the cryptography. And there is a separate course in cryptography also. Network security contents you can understand by yourself also if you read the book. Okay, so that's all about today's class. Tomorrow there will be no class, and next class will be next Monday. So if you have any questions for today's class, you may ask me before we end the class. Okay. Okay. Thank you. And if any one of you are more interested in any part of the things that I am delivering,